Okay, so finally we're going to move on to our last lesson and property, which is free energy. It's also called Gibbs free energy, so that's where our symbol of delta G comes from. And so basically this guy is kind of like a combo between enthalpy and entropy. So the formula for it, you can see, depends on both because we've got delta H in there and we've also got delta S. And so when we're looking at whether a process is spontaneous, basically whether it can happen without the help of additional energy, delta G really is the king here. So it really has the final say on whether a reaction is spontaneous or not. So make sure you know these rules here. So when delta G is negative, the reaction is spontaneous. And then when delta G is positive, the reaction is non-spontaneous. And a special case is when delta G is equal to 0. And this happens with phase changes, so like melting or boiling or freezing. And then once you've got that kind of internalized, the next thing that you're going to want to tackle is this chart here. So this basically just goes through all the scenarios of like delta H and delta S being positive or negative, what kind of effect that has on delta G, and then the spontaneity of the reaction. And so yes, you can memorize this, but it's also all like based on this equation here. So you can try out the different signs and see that like it mathematically makes sense. So for example, if we looked at the first scenario up here, we have delta G, and so we'll have a negative value for delta H, and then a positive value for delta S. And so when you multiply this and this, that's going to give a negative value. So you're essentially doing a negative value minus another negative value. So obviously that's going to make delta G negative. And so you can see that as you go through the different scenarios. Just with these two bottom ones, it will depend on the temperature, whether it ends up being spontaneous or not. All right, and then finally we have one more equation and calculation, which is calculating standard free energy change. But guess what? This is exactly the same as the formula that you saw for enthalpy and entropy. So same idea, these standard free energy values would be given to you. You would sum them up, just make sure you're multiplying by your coefficients, and it follows the exact same format as your other calculations. So we will end off with a practice question related to free energy. So this one says, estimate the boiling point in Kelvin of methanol. And they give us data for methanol as a liquid and then methanol as a gas. And we have our enthalpy and our entropy. So the really key thing that you want to remember for this question is that at phase changes, so this is a phase change because we're seeing boiling. At phase change, delta G is equal to 0. So we can take our formula, delta G equals delta H minus T delta S, and we can set this side to 0, and then we're going to calculate our delta H. So we're going from CH3OH liquid to CH3OH gas. So this is our initial, and then this is our final. So for delta H, the change in enthalpy, we're going to do our final minus our initial. So we'll do negative 201.2 kilojoules per mole minus negative 238.6, and I'm actually just going to move this just so there's a little bit more room here. Okay, and then minus T. So T is what we're trying to solve for. We're trying to find the temperature at the phase change when delta G is equal to 0. And delta S, we're going to do the final minus the initial, so we'll do our gas value of 238 joules per mole per Kelvin minus 127. And I don't have room for my units there, but we'll just leave it like that. It's the same units. So let's calculate this. So this is going to be 37.4 kilojoules per mole minus T times 111 joules mole. Okay, and then this is the thing I was talking about before. Enthalpy and entropy have different units. So we're going to want to make sure that we convert, make them equivalent. So I think it's just easier to convert this to joules by multiplying by 1,000. So we'll get and I'm just going to move this up. And so just rearranging for T, I'm going to move this over to the other side. Sorry, this should be joules here. And I'll just switch my color so you can see it on the purple here, but T is going to be equal to 37,400 joules all over 111. Again, I just got rid of we have negatives on both sides, so they just cancel out. And then the joules per mole units will cancel out. We're left with 1 over Kelvin to the -1, which is just Kelvin, so that'll give us our temperature answer. So this gives us 336.9. It's pretty close to 337, which is D. So that's our answer.